Hello young friends, this video is being brought to you by Rao Scientific Society. So the series of videos which we are going to show you will help you to understand the fundamental scientific principles which you see around you, and it will help you to develop friendship with science. What I have here is another version of Maxwell's wheel, but normally this is called a yo-yo. Here as well, I have wound the string around this object, which is almost like a cylinder, and then I release it. Now watch carefully what happens when I release it. It unwinds and then winds back on the other side. Okay? So this is exactly like Maxwell's wheel, but the advantage with the yo-yo is that you can do other things as well. I wind it up, now I place it on the table. I place it on the table and then let's see, I am going to pull this string. Now it's going to rotate and roll on the table. But the question is, which way will it go? Will it come towards me or will it go away from me? Let's see what happens. Now before I do this, think carefully and pick your answer. Is it going to go away from me or come towards my hand? Let's verify this. What happens? So as I pull, obviously it's going to come towards me. Okay? Now you might have thought otherwise, but there is a very simple explanation. Common sense says that if I pull something, it's going to come towards me. But if you analyze this more deeply, there are other things at play. So what is happening here is that when I place it on the table and then I pull, there is friction between the yo-yo on the table. And what is the direction of the friction? Now since I am pulling it towards my hand, the friction will act in the opposite direction, away from my hand. But the frictional force, you know, is always less than the applied force. And that is why the applied force, that is the force which I am applying, wins over friction, and the resultant force is towards my hand. Right. But then this object is also rolling, and when it's rolling, it is rolling like this. So therefore, if you look at this, the torque provided by friction should be greater than the applied force. Now, even though frictional force is less than the applied force, the torque due to friction is greater than the applied force. How is that? The explanation again is simple if you consider the construction of the yo-yo. If you see here, the axle around which the string is wound has a smaller radius than the radius of the yo-yo itself. Now the torque due to friction will be the frictional force multiplied by the radius of the yo-yo, whereas the torque due to my force, whatever I am applying, which is nothing but the tension in the string, will be the tension multiplied by the much smaller distance of the radius of the axle, and therefore the torque due to friction is greater than the torque due to the applied force, even though the friction itself is less than the applied force. Fine? So even though at first hand, if some demonstrations look trivial, if you analyze them more closely, you can learn more. And always remember, in physics, what matters is experimentation. Experiment and verify your fundamental principles, and that way you can get rid of many of the misconceptions which you have. I hope you could learn a lot from this simple demonstration of Maxwell's wheel and this yo-yo. Thank you.